All right, here's our first video in section 6.2. We're going to start talking about multiplication and division of rational expressions. So we've talked about domain restrictions, remember what's going to cause the denominator to equal 0, and we've talked about simplifying rational expressions. Now let's talk about multiplying. Now remember, when we have fractions and we're multiplying, we could just multiply straight across the top and then straight across the bottom. We can multiply our numerators and then multiply our denominators. There's no need for a common denominator when you're multiplying. Just multiply across the top and multiply across the bottom. Now, we always have to make sure that we reduce, and you can do this a couple different ways. You can cross-reduce first. Any factor from the numerator that can reduce in any factor in the denominators, you can cross-reduce. Not cross-multiply, but cross-reduce. Or you can reduce the original fractions first. If the individual fractions can be reduced first, then you can always do that before you multiply. Or you can reduce after you multiply. Any of those options would work, just be careful. So let's go back to just basic fractions. If I have a 1/4 times a 2/3, I don't need a common denominator when I'm multiplying, only when I'm adding or subtracting. So when I multiply fractions, I simply multiply across the numerators, 1 times 2 is 2, and multiply across the denominators, 4 times 3 is 12. I end up getting a fraction of 2/12. And then I can see if I can reduce. So what GCF, what number, can I divide into 2 and 12 so I can reduce or simplify this fraction? It looks like I can divide both of those by 2. So 2 divided by 2 is 1, and 12 divided by 2 is 6. So my final reduced answer would be 1/6. That's one option. Some of you might have cross-reduced. Maybe you noticed that there was a GCF of 2 and 4. So I can divide 2 by 2 and get 1, and then 4 by 2 and get 2. Then I have 1 times 1 on the top, and I have 2 times 3 on the bottom, which still gives me 1/6. Either way would work. All right, what happens if I start adding some variables in there? So like this one. I notice that I'm multiplying fractions, so I know when I multiply fractions, I can simply multiply the numerators and then the denominators. So that's what I'm going to do first. I'm going to multiply my numerators together and my denominators together. That gives me a 28x to the third over 20x squared. And then I can reduce. So what number, what GCF, can I divide into 24 and 20, and then into x cubed and x squared? It looks like I can divide each of these terms by a 4 and an x squared. I'm going to divide my numerator by 4x squared and my denominator by 4x squared. 24 divided by 4 is 6. X cubed divided by x squared is x. 20 divided by 4 is 5, and x squared divided by x squared reduces, or I get 1. So 5 times 1 is just 5 in my denominator. I have a 6x on top and a 5 on bottom. That can't be reduced anymore. So that would be my final answer. Let's keep practicing. Again, remember, there's no need for a common denominator when you're multiplying or dividing. And any term on top can reduce with any term on bottom as long as they're not connected with a plus or minus sign. They have to be factors of multiplication, not addition or subtraction. All right, let's multiply and simplify example number 1. I'm going to multiply across my numerators and multiply across my denominators. On the top, I end up getting a 10a cubed. On the bottom, I get a 20a. And now let's see if we can reduce. I have a term on the top and one term on the bottom. And what GCF can I take out of both of those terms? It looks like I can divide both the numerator and the denominator by a 10 and an a. 10 divided by 10 is 1. A cubed divided by a is a squared. So I end up getting an a squared on the top, or a 1a squared on the top. On the bottom, my denominator, 20 divided by 10 is 2. A divided by a is 1, so 2 times 1 is 2. I end up just getting a 2 in the denominator. So my final answer would be an a squared over 2. That's as simplified as we can get it. All right, look at B. B looks a little bit different. We've got a lot of things going on in B, right? What I suggest you do is try factoring all of your fractions first, all your rational expressions. If you look at the first numerator, the x squared minus 16, it looks like that can be factored as a difference of squares into an x minus 4 and an x plus 4. If you look at the denominator, it looks like I can GCF out a 4, leaving me with an x plus 3. So when I go to multiply my fractions, I have 1, 2, 3 factors on the top. I have an x minus 4, I have an x plus 4, and I have an x plus 3. On the bottom, I have a 4, I have an x plus 3, And I also have an x minus 4. So I wrote all the factors of my top being multiplied and all the factors of my denominator, my bottom, being multiplied. And now look, as long as they're not connected with a plus or minus sign, and as long as one whole factor on the numerator can reduce with a whole factor from the denominator, it looks like I can reduce. So what are some common factors? Well, it looks like there's an x minus 4 on my numerator denominator. It looks like I can divide by an x plus 3 on the numerator and denominator. And then look what's left. I have an x plus 4 on my top and a 4 on the bottom. Now be careful, don't reduce off those 4s because you can't reduce a 4 from everybody. So it looks like that would be my final reduced answer. So maybe try factoring first if that helps. Look at C. C looks a little bit different. If I gave you the number 7, would it be okay if I wrote that 7 as 7 over 1? Right? That means the same thing. So when I give you this one on C, x squared minus 3x minus 10, could I write that with a 1 on its denominator? I don't know why, but it makes me feel more comfortable to have two fractions next to each other. So I always like to write that with a 1 in my denominator, so it looks like a fraction, like the one next to it. And then I notice that all of those pieces look like they can be factored into smaller pieces. Those polynomials can be factored. So I'm going to factor this x squared minus 3x minus 10 using my basic factoring. I factored it into an x plus 2 and an x minus 5, and there's my 1 as my denominator. In my other fraction, it looks like the numerator is already factored, but it looks like my denominator can be factored a little bit more with a basic factor into an x minus 5 and another x minus 5. So now that all my pieces are factored, if I'm multiplying, remember my numerators go together and my denominators go together. On the top, I have factors, 3 of them, an x plus 2, an x minus 5, and an x plus 4. On the bottom, I have an x minus 5 and another x minus 5. You could put the 1 in the front if you wanted to, but we know it's invisible and it's still there. Now, is there any factor on top that can reduce with any factor on bottom? Looks like there's a common factor of an x minus 5. So I can divide off an x minus 5 from the top and the bottom. That leaves me with an x plus 2 and an x plus 4 on my numerator and an x minus 5 in my denominator. There's no other common factor, so that would be my final reduced answer. All right, try the same thing with D. See if you can factor all of your pieces, put your numerators together, put your denominators together, and see if you can reduce with a common factor. All right, here we go. On D, on the top left, I looked for a GCF of a 10. That left me with an x plus 2. Now my denominator, that's kind of tricky. Remember, that was a bottoms up. So if you remember your bottoms up factoring, and you factored it, it should factor into an x minus 1 and a 2x minus 1 using bottoms up. All right, look at the right fraction. It looks like that numerator is a difference of squares, x minus 1, x plus 1, and it looks like the denominator has a GCF. Each term I can take out of 5. That leaves me with an x plus 2. Now I have two fractions all factored that are being multiplied together. Remember, we can put our numerators together and we can put our denominators together. So my numerator has a 10, it has an x plus 2, it has an x minus 1, and an x plus 1 as different factors. In my denominator, I have a 5, I have an x minus 1, a 2x minus 1, and an x plus 2. All right, can I reduce? Well, if you notice in the numerator, we have an x minus 1 and an x minus 1 in my denominator. Oh, isn't there an x plus 2 and an x plus 2 that I can reduce? And since my 10 and my 5 are not connected with a plus sign, they're simply still factors being multiplied by, it looks like I can reduce the 10 and the 5 together as well. So I ended up getting a 2. I have the x plus 1 still on the numerator, and I have a 1 and a 2x minus 1 in my denominator. You can keep the 1 there, or we know it's invisible. It looks like there's no other factor. Be careful not to reduce the 2's. It looks like that would be my final answer. All right, let's do some more. Maybe pause the video, factor all of your pieces for E, and then let's put them together and see if we can reduce. All right, on the left fraction, it looks like the numerator is a basic factor, so I factored it into a k plus 5 and a k minus 3. My denominator is a basic factor. I have a k minus 3 and a k minus 1. On my right fraction, it looks like I can GCF out a k. That leaves me with a k minus 1. And it looks like the bottom is a basic factor. I can factor it into a k plus 5 and a k minus 4. Now I notice that I'm multiplying, so really my numerators go together and my denominators go together. Are you okay if I make that into one big fraction bar then? All my tops go together, all my bottoms go together, and let's see if I can reduce any factor from the top and the bottom. It looks like I have a common factor of a k plus 5. I have a common factor of a k minus 3. Ooh, and I even have a k minus 1 on both the numerator and the denominator. What does that leave me with? It looks like I'm left with a k on the top and a k minus 4 in the denominator. I can't factor anymore, can't reduce anymore. It looks like that would be my final answer. Remember, don't reduce the k's because the k minus 4 is connected with that minus sign. Again, if it helps you put parentheses so you know they're protected, that might help. All right, let's look at F. On F, I'm multiplying fractions. It looks like this numerator is already factored, and it really looks like that denominator is already factored. It really only looks like this second denominator is the only one that can be factored. All right, let's write all of our factors of our numerator. On my top, I have an 8x cubed, and I have an x minus 3. On my denominator, I have the x squared, and then if you were to factor this with a basic factor, you end up having an x minus 3 and an x minus 1. So I've broken down my numerator and denominator into a whole bunch of different factors. Now, is there a common factor in my numerator and denominator? Well, it looks like I can reduce off an x minus 3 from the top and bottom. And now be careful. You notice that this x cubed and this x squared aren't connected by plus or minus signs. They're just being multiplied by. So they're just factors of. And so if both the numerator and denominator have a common factor, we can reduce. So it looks like I should be able to reduce each of those by an x squared. I can take an x squared out of that and an x squared out of that, leaving me with an 8 and an x on the top, and then my x minus 1 on the bottom. So because they're not connected by a plus or minus sign, we should be able to reduce the 8x cubed, or the x cubed anyway, and the x squared from the denominator. All right, make sure that you practice those, and in the next video, we'll talk about what happens when we divide these rational expressions. So make sure that you practice your multiplication, so when it gets harder and we do division, you already have a solid foundation.